Our topic for today is finite differences and interpolation. What is interpolation? First of all, let's understand this. Let's say we have values of x and values of y we have been given at 5, 10, 15, 20. Let's say we have 7, 8, 10 more values. For the timing, we have 4 values of x and we say that y is 1, 1.2, 1.3 and 1.4 for x equal to 5, 10, 15 and 20. Okay, we don't know what the function is. Now, based on this data, if we are asked that what is the value of y at x equal to 7, that is, you have data from 5 to 20, 5, 10, 15, 20, you have the value of the function at these values, and you want to find the value of the function at a point for which the data is not given, but that is within the range of data given to you. This is called interpolation. That is, you devise a mechanism by which you are able to approximate the value of y at x equal to 7. Okay, this process is called interpolation, that is within the range, inter. Now, what if you are asked to give the value at 22? Now, this is beyond your range, but based on the nature of the function, the input is there and the output is there, and you can have a function, you can create a function whereby you can approximate the value out of this range also. That mechanism is called extrapolation. So you understand what is interpolation and you understand what is extrapolation. That is, if graph is plotted, we have this graph from x equal to, let's say, 5 to x equal to 20. Actually, we don't have graph, we have points 5, 10, 15, 20. So we know the values like this, and if we are able to approximate this graph as when we find the function, we actually find the curve, so that we are able to tell the value at this point. This is interpolation. And if we are able to tell the value of the function at this point or this point, that is outside the range of the data provided to us, then it is called extrapolation. Clear? And what we essentially do, we create a polynomial whereby we get very close to the actual value that the curve would take. Okay, clear to you? So this is interpolation and extrapolation. Now, the second thing, how do we solve this? How we are able to interpolate or extrapolate? We do this by a method employing a technique which is called finite differences. What are finite differences? Let's say our value is 5, 10, 15, 20. So we can say this as, let's say this is x0, this is x0 plus h, where we have h equal to 5, this is x0 plus 2h, x0 plus 3h. Okay, so we have differences in the variable, that is, the difference between 2 points is h. If this h is equal, if the differences are equal, it is called finite differences with equal intervals. And if we take the values which are not equal, we have particular relation between these values. Let's say this is h1, this is h2, h3, definitely they are in an order, then it is finite differences with unequal intervals. So we will see both of them. So what we essentially do, we construct a difference table whereby we have values of x. First is x0, second is x0 plus h, x0 plus 2h, x0 plus 3h, and so on. And we have values of y. let's say for this is y0, y1, y2, y3 and so on. Then we construct a table where we take finite differences, let's say this minus this minus this, we create a whole table. Then what we do, we use these values to actually find a polynomial wherein these figures are used, and from where we are able to interpolate, for now interpolate the value of this y at some value of x which is not given in the table. Okay, so first is we create finite difference table. Then we use these values. For example, if this is y1 minus y0, just understand this is y2 minus y1. Similarly, this is something, this minus this or something. Now we use these values to formulate a polynomial in x. Let's say an minus 1, xn minus 1 and so on. And this polynomial uses these points, the finite differences, and we are able to put the value of x and approximate the value of y. This Pnx is actually y. So we are able to formulate it. So the first step is to construct finite difference table. Okay, understand this. First step is to construct finite difference table. Second step is there are operators by use of which we create finite difference table. So operators and their relations, we will understand this. And then finally we have several techniques for interpolation and extrapolation. Techniques for interpolation, for example, Newton's forward difference formula, Newton's backward difference formula, then we have Gauss's formula. There are so many techniques to find or at least approximate the value. So this is first step, this is second step, and then finally we will see different techniques. Okay, so I'll start with this today, finite difference table. Let's start with forward differences table. It's very simple. The formation of table is very easy. You should have patience and see it. How do we create forward differences table? First is the operator. This is called forward difference operator, del. And what is its meaning? Del of yr means del of yr plus 1 minus, sorry, not y, del yr plus 1 minus yr. That is, if I say del y0, this means y1 minus y0. When I say y1, it means y2 minus y1. Okay. So this is del yr. This is operator. So when we put operator here, like dy by dx, this is an operator. Similarly, this is an operator. Clear? Then, as we have orders in differentiation, d2 second order is d like this. Similarly, we have second order operator. This is del 2 yr. This is nothing but del of yr plus 1 minus del of yr. Okay. Similarly, directly I am writing del p of yr. How will write? See, when it was 1, this is 0. This is 2, this is 1. So p means del of p minus 1 yr plus 1 minus del of p minus 1 yr. Okay. If this seems complicated, don't lose your patience. This is very easy. One of the easiest topics in higher mathematics. Okay. So how do we compute the forward differences table? See, The first is value of x, second is value of y corresponding to x. So let's write down. This is x0, we have this is y0. This is called the leading term. The first term in every, the first row where we find the first term, in every column, the first term is called the leading term. So this is x0 plus h, then x0 plus 2h, x0 plus 3h, x0 plus 4h, x0 plus 5h. Okay, let's say we have these 6 values. Corresponding to this, we have y0, y1, y2, y3, y4, and finally y5. Now, this column is first difference. First difference, that is del y0. What it will be? It is this. That is y1 minus y0. Okay. Then del y1. That is y2 minus y1. Then del y2. Okay. Then we have between this and this del y3. And between this and this del y4. Okay, I am rubbing this. Then we have second difference. Second difference will be between this and this. So this is del 2 y0, which is del y1 minus del y0. Okay. So del y0. Then between this and this, del 2 y1, del 2 y2, del 2 y3. Okay. Then third difference, del 3 y0, this minus this, then this minus this is del 3 y1, and this minus this is del 3 y2. Okay. Then fourth, this. So this is del 4 y0, this is del 4 y1, and finally fifth, it is this one only, del 5 y0. Okay. So what do we see? It is reducing. With every forward column, the number of terms is reducing. This has 6 entries. This has 5, this has 4, 3, 2, 1. So if we have 6 entries here, or if we have 5h, see the difference, finite difference. If we have 5 differences from the leading term, we have 5 difference only where we'll have this thing, and then we don't have any other term in the next column, because it's always this minus this, so we have only one term. Then from here what we have? 0. Okay. So this is called forward differences table. Clear? Now the second is called backward differences table. First of all, just understand the different types of tables, then we will see how we use them for constructing tables and then finally creating polynomials. See, backward difference table, the operator is like this. There we had del forward difference table, this is reverse, that is backward difference table. And what is here? This is yr minus 1, that is y1 is equal to y1 minus y0. So y1 minus y0, there it was, this was there like this. Okay, but y1 minus y0, for example, y1 minus y0 in forward difference table we write it as y0. But here what do we write it? We write it del y1. Same thing. The result is same, but our notation, our operator is different. And so every other will be same. If we take the second order operator, this will be del yr minus inverse del yr minus, and so on. Okay, so our table will be, again, if we have, let's see, x0, then x0 plus h, x0 plus 2h, x0 plus 3h. Let's say we start from here only. So this is y0, y1, y2, y3. Then this is del y, this time it will be 1. So this is y1 minus 0, this is del y2, and this is del y3. Second, this will be second order. What is this? y2 minus y1. So here we will start with y2, y3, and third we have this only. We won't have any fourth and fifth difference column. These all are 0. Okay, since we took 3h only, this has closed at the third column. Clear? So this is backward differences table. Now we have a third type of difference table, which is called central differences table. Central differences table. The operator here is del, and we present it like this. As I told you, y1 minus y0, that is the only difference that we have to take. In forward difference table, we call it del y0. In backward difference table we called inverse del y1. Here what we call first difference, we call it as half. That is the average of these. 1 and 0. 1 plus 0 by 2, that is half. So here we will have 2 plus 1, that is, okay, and here we will have 5 by 2. But essentially what you have to understand, that what we get is y1 minus y0. The only thing is, we write in forward difference table, we write it as y0. In backward difference table, we write it like inverse y1, and here we call it del half. The matter is same. Our formula, our mechanism, or our technique for interpolation and extrapolation will differ based on operator, but the table will be same whatever you use. Okay, so this is this again. Now here what we'll have, this plus this by 2. So this is 3 by 2 plus half. What is it? 2. 2 by 2, that is 1. This is 2. Okay, or you can see half and 1.5. So 1 will be in between. This one will be 2 plus 1, that is 3 by 2. Okay, so in this way we proceed in central difference table. Clear? So this is the part that is to be understood clearly, and you should be able to create a table. If you have, 5 plus 5, 5 plus 2, 5, 5 plus 3, 5. So you should be able to create the values. For example, if is at this point, I give this, like this is 5, what we took in the start only, 5, 10, 15, 20. Okay, so this is 5, this is 5 plus 5, this is 5 plus 2 cross 5, this is 5 plus 3 cross 5. Let's say our value is 1, 2, 3, 4. So first difference will be 2 minus 1, that is 1. This is 3 minus 2, that is 1. And this is 4 minus 3, that is 1. Second table, this is 0, this is 0. Third, this is 0. Clear? Or if we give some other value, let's say 5, 9, 15. What is it? This is 5 minus 1, that is 4. 9 minus 5, that is 4. 15 minus 9, that is 6. Now 4 minus 4, 0. 6 minus 4, 2. Then 2 minus 0, 2. So this is the difference table. This is 4 is, you can say it as del y0, or you can say it inverse del y1 or del half. The value is this. Okay, so these are operators only, and the importance of operator, because a natural question will be, if all are same, why do we need these? We need this because we have several techniques. Some techniques are based on this forward difference formula, some techniques are based on reverse backward differences formula and some on central differences formula. So whatever it will be, we'll understand the technique. We'll use this table to fill in the gaps and find the value. Okay.